Good morning, class. Today, we are going to continue in our math section of the day and talk about two-dimensional shapes. That's a pretty big word there. Dimensional. Can you guys say it with me? Dimensional. What do you guys think that means? We have the number 2 and we have the word shapes. When we put that all together, two-dimensional shapes, what do you think they're referring to? Okay, well, I'll give you guys a hand. For example, here we have a triangle. Triangle, that's correct. Now notice how when we're looking at the shape, we are looking at it from a point of view from up top. So it is laying on a flat surface, so to speak, right? So two-dimensional shapes, all that means is that we're looking at a flat shape and we're not able to look at it from a different angle or side. Now, this might seem a little cool, but here is a three-dimensional shape. And so as you can see, we're not only just looking at the front of this cube, right? Because you look at the top of the cube, the front of the cube, the sides of the cube, and then the bottom of the cube. As compared to when we draw a regular square, this is a two-dimensional square. As you can see, we can only see one side of the surface, and it's flat. So just keep that in mind whenever we're going over our shapes today, that we are only going to be going over two-dimensional shapes. And today's objective is, once we're done with our lesson and kind of get a little bit of practice, we are going to be able to describe two-dimensional shapes based on attributes. Now that's a pretty big key word right there, attributes. What do you think that means, class? Attributes, it's a pretty big word. I'll give you a hint, check it out. We can describe two-dimensional shapes based on attributes. So what's another key word we see there? Describe. So attributes, all that means is characteristics used to describe a shape. So for example, we have here a triangle. That's correct. What can we say about this shape? Triangle, right? Which we all know is a triangle, without actually mentioning the name of the shape. So how would you describe this to your classmate next to you, right? We can say that it has 1, 2, 3 sides, which is one of our vocabulary words, sides, right? So you see how we are using different ways to describe what the shape is. We can also say that it has 1, 2, 3 corners, right? 3 corners. We can say that the sides are straight, right? What else do we have? The sides are different lengths. Good job. This side right here is a little bit shorter than this side here, but doesn't change anything. They're still sides. They are still part of the shape. Now, if a figure has 3 corners, right? 1, 2, 3. That means it also has 3 angles. Angles, another vocabulary word. So whenever 2 points meet, they create, and you'll see it on your assignment here shortly, 3 angles, and it's labeled by these half circle drawings that are drawn inside of the angle. An angle is the figure formed when 2 sides meet. All right, so once again, we have a triangle. Triangle. And if somebody asks you, could you describe this triangle based on its attributes? So if you didn't know what the name of the shape was, you'd be able to say that it has 1, 2, 3 sides. You'll be able to say that it has 1, 2, 3 corners, which also means that it has 1, 2, 3 angles. And now I'm gonna go ahead and throw in another vocabulary word in there. Is this shape considered a closed shape or an open shape? What do you guys think? I would consider it a closed shape. And the reason for that is, as you can see, this shape itself is enclosed without leaving any availability or space for it to be open, so to speak. So it's not a closed shape. I mean, it is a closed shape. It is not an open shape. And I'm going to draw you an example of what an open shape looks like, just so you can see. We're going to draw a triangle. Oh, that's about it. Do you think this is a closed shape or an open shape? Open, correct. And why is that? Because we have an open space on one of its sides. So this shape here has 1, 2 sides, but it doesn't have the third side. That makes it a triangle, right? So this is a closed shape because it's closed, right? And this is an open shape. And one way to remember this is, for example, whenever you're about to take a bite out of your meal or a burger or your pizza during lunch, you go ahead and open your mouth. And as you can see, there's an angle here, which means it's an open mouth, open shape. So if you have a hard time remembering, just think of your mouth being open. And that's open. If you have your mouth closed, you're chewing with your mouth closed, right? Yum, 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 yum. You have a closed shape. So that's just a really good way to remember that. That is awesome. All right. Here we are. Now we're going to be looking at another shape. Hope you guys are ready for that. So we're going to get this cleaned up for us. Sorry for my board. My dry erase board's a little weak sauce. We are going to be okay. So here we are. We're going to draw another shape. That looks a little wonky, doesn't it? It looks a little wonky. How would you describe that shape? Or you know what? Let me, because that was kind of an ugly shape. Let me draw. All right. Now, it might look a little wonky, but that's meant to be it could be considered a square, but I would categorize this more as a diamond. So if you ever watch baseball or play baseball, you have a diamond shape on the pitch. We have a diamond. Now, let's pretend like we did not know what the name of the shape was. How could you describe this two-dimensional shape based on its attributes? What can you say? Yes, you can say that it has 1, 2, 3, 4 sides. Correct. What else can you say? Yeah, it has 4 angles. And where are those angles located? 1, 2, 3, 4. Great job, great job. What else can we describe? What else can we describe? What other attributes can we see? How many vertexes does it have? Whoa, that's another big word, huh? Vertex. Does anybody know what the word vertex means? Not quite exactly. The vertex is where the sides of the angle meet. So you have 1, 2, 3, 4 vertexes. So we're going to add that in there, 4 vertexes. 4 sides, 4 vertices. Oh, forgot to throw that up there. 4 angles. Another one of our keywords. And lastly, would you consider this shape to be open? Open mouth, think of your open mouth. Ah. Or a closed shape, think of your mouth closed while you're chewing your food. Good job. It is considered a closed shape. Great job, class. Great job. All right, now it's your turn. So on the board, I want you to create a shape with 4 sides, 4 angles, but that looks different than mine. So you can't do a diamond and you can't do a square. Who would like to come up? Or actually, you know what? Instead of doing shapes that have attributes of 4 sides, 4 angles, we're gonna make it a little bit interesting. I want you to do 5. I want you to do a 2-dimensional shape that has 5 angles, 5 vertices, 5 sides. Okay, I'm gonna give you guys a couple minutes and we'll draw your examples up on the board. All right, thank you class for giving us those examples. So we are going to start with our first shape. All right, let's start with our sides. How many sides does this shape have? And if you pay attention, it kind of looks like a house, right? So we have, count with me, 1, 2, 3, 4, 5. It has 5 sides. Great job. How many angles does it have? Let's count where our lines meet. 1, 2, 3, 4, 5. Again, 5 angles, which in return means we also have 5 vertices, right? Great job. And is this shape considered closed or open? Do you guys see an entry, an opening inside of the shape, or is everything closed? VIP only. Everything is closed. Good job, you guys. Remember, think of your mouth. Open your mouth. Think, is it open? Ah. Or is it closed? Now this one looks a little wonky, and let's see if it shares the same attributes or characteristics as our first shape. How many sides does it have? We have 1, 2, 3, 4, 5. 5 is the magic number. Great job. How many angles does it have? We have 1, 2, 3, 4. And do we see a 5th one? Ah, this one's a little tricky. Even though the shape is shaped interestingly, the angles, not only can they be on the inside of the shape, they can also be on the outside of the shape. So this angle right here, where it intersects, the angle is actually going to be on the outside of the shape. Now, is this shape considered open or closed? Do you guys see an entry? Do you guys see a mouth open? No, you do not. So that means it is a closed shape, but in return, you do still have 5 sides. You do still have 5 angles, right? 1, 2, 3, 4. The 5th one outside of the shape. Now, these two shapes, even though they're slightly different or very different, let's just be honest, they're very different. It still shares the same attributes for one another. It still has 5 sides, it still has 5 angles. They're both considered a closed shape, and they both have 5 vertices. Isn't that really interesting, guys? How shapes can be different but still share the same characteristics? Kind of like people, kind of like a lot of things where, hey, Tommy and Timmy might not be from the same country, but you guys both share a love for TV or Stranger Things or bicycles. So that's really, really neat how math can parallel life in terms of we might be a little different, but we can also have a lot in common, just like in life. All right, class. What we are going to do next, now that we understand how to look at attributes on 2-dimensional shapes, we're going to hand out an activity for you guys. And you are going to get a good number of shapes. And for each shape, A through I want you to tell me how many sides each shape has, how many angles it has, and how many vertices. Now for all shapes, these are the three attributes that I'm asking you guys to label for each shape. But I also do want you to keep in mind, is it a closed shape or is it an open shape? All right, so very, very important that we are able to identify that, because that'll come into play a little bit later once we start learning about three-dimensional shapes, right? Thank you guys, and we'll pass out the forms and we'll get started. I'll be walking around making sure you guys are on task, and if you have any questions or doubts, I can chime in and help out. All right. Oh, before we get started, one more thing. What is our objective for today? Describe two-dimensional shapes based on their attributes, based on their characteristics. Good job, you guys. Let's get started.